Hello everyone, in this video I am going to discuss about the conversion of finite automata to regular expression. To prove that both of these are equivalent, we are just converting from finite automata to regular expression. So I am just going to convert this to regular expression with the help of the state elimination method. So the regular expression can be generated from finite automata by using two methods. One is state elimination method and another one is formula method, some general method. So here already I have discussed the formula method in the previous video, and in this video I am just going to discuss about the state elimination method. So by applying state elimination method, how the regular expression can be generated from finite automata, we are just going to discuss in this session. So generally we will take one random example first. So here this is the example, some random example I have taken actually. So by eliminating this state one by one only, we are just going to frame the regular expression. So whatever the diagram, whatever the model, DFA model or NFA model you take, there will be more than one state definitely. So finally, until there is only initial state and final state exist, we are supposed to eliminate the state one by one. So other than the initial state and final state, we are just going to eliminate the state one by one by using this state elimination method. We'll take this random example here. So if you take this random example, totally there are 5 states are there: Q1, P1, S, QK and PM. So totally there are 5 states are there. Suppose you want to eliminate, so like how we are just going to frame the regular expression by eliminating the state one by one. So it's just for example, we are just going to eliminate the state S now. Fine. So after eliminating the state, how the diagram will be, how all these inputs will be, we are just going to check now. So after eliminating this S, only 4 states only must be there, and also you are supposed to check before eliminating, you need to check whether S is acting as an intermediate state or not. You are supposed to check. Yes, definitely the state S is acting as an intermediate state for the state Q1 to PM. If you take the path from Q1 state to the PM state, S is acting as the intermediate state, Q1 to S to PM. Fine. To reach from the state Q1 to PM, S is acting as an intermediate state. And also if you take the state QK and P1, yes, for these two states also S is acting as an intermediate state. From QK through S only we are able to reach the state P1. So if you see, only for two paths it is acting as an intermediate state. One for Q1 and PM and another one for QK and P1, it is acting as an intermediate state. So after eliminating the state now, it can be, shall we write like this? For example, we need to travel from Q1 to from the state Q1 to the state PM without the state S actually. So now we can directly connect the state. After eliminating the state S, we can connect directly these two states. After connecting these two states, we need to write the expression. So after eliminating the state one by one, will be some expression will be generated. That expression you are just going to attach along with the existing input symbol, existing expression or variable over here. So if you take, to reach from the state Q1 to S, the input symbol is Q1, and from the S again we have a self loop, that is S star, and also again from the state S to PM there is again one outgoing path, outgoing arrow is there with the input symbol PM. So shall we write like this? Q1 is the incoming transition for the state which we have eliminated, and S star is the self loop of the state which we have eliminated, and PM is for the outgoing transition which comes from the state which I have eliminated, right? So Q1, S star and PM, and also you just check, is there any other path existing to reach from the state Q1 to PM? If you check, we have another path also to reach from the state Q1 to PM, that is through R, with the help of R1M input symbol we can travel from the state Q1 to PM. So that also you can add. So to reach from the state Q1 to PM, we have two possible paths, one through R1M and another one through Q1 S star PM. R1, yeah. So either with the help of any one of these input, we will be able to travel from the state Q1 to PM. Same like Again we have, okay fine, for Q1 to PM we have finished it, right? So the incoming path we call it as Q, the outgoing path, outgoing transition we call it as P, and the self loop we call it as S star, right? Then again S is acting as an intermediate state again for QK and P1. Now okay fine, you check QK and P1 again. Q, after eliminating the state S, it can be written like QK S star P1. This is one of the possible path. How it can be written? QK S star P1, and also the another possible path to reach from the state QK to P1 is this one, RK1. So either RK1 or QK S star P1 can be used to travel from the state QK to P1. And again we have another transition here, right? So to reach from Q1 to PM, sorry, yeah, I'll write here. To reach from Q1 to P1, this is one of the path, that is what? With the help of R11, and another possibility is again the S is acting as the intermediate state for Q1 and P1. So it can be written, this is one of the path to reach from the state Q1 to P1, and this is also one of the path. So it can be written as R11 or Q1 S star P1, right? Then again to reach from the state QK to PM, this is one of the path, that is RKM, and another path is again S is acting as the intermediate state for QK and PM. So it can be written like QK S PM, right? Fine. So how it can be written? QK S star P1. So we have two possibilities. To reach from Q1 to P1 also we have two possibilities, one through R11 or else Q1 S star P1. To reach from Q1 to PM again we have two options, either R1M or Q1 S star PM can be used to travel to make a transition from Q1 to PM. And then again to reach from QK to P1 again we have two possibilities, that is QK S P1 plus R K1. Then again QK to PM again we have two possibilities, right? So here shall we frame this as one formula, that is some R parameter will definitely be there, or some Q parameter along with S closure S star parameter as well as P parameter will definitely be there everywhere. Fine. So shall we frame it as one formula? The R is going to indicate the direct connection, and Q is going to be the incoming transition to the state which you are going to eliminate. S is going to be the self loop of the state which you are going to eliminate, and P is going to be the outgoing transition. So to eliminate any of the intermediate state other than the initial state and final state, all other states we call it as the intermediate states. So if you want to eliminate any of the intermediate states means this formula can be applied directly. Finally, so one by one you have eliminated all the intermediate states other than the initial state and final state, for example. So in that case I have just made, finally there will be only two states remaining, right? So I have made all the possible transitions here. For example, randomly I have just made it here. The possible transitions are either from Q0 to Q we can make one transition, or else Q to Q0 one possible transition is there, or else one self loop from the initial and one self loop from the final. So these are the possible transitions I have made. Fine. How can you frame the regular expression for this? So while seeing this diagram, what can be understood here is definitely the ending must be SU star. Without SU star we won't be able to reach the final state. So the ending must be always SU star. What about the beginning? So the beginning can be either R star or SU star, then again T star, SU star T also, R star, or else ending will be definitely SU star. So either the input will be R along with SU star, else SU star T, then again SU star T, then again SU star T, like that likewise any number of times it can be accessed, the possibilities are there. So it can be written as S U star T, and or also can be accessed any number of times. So or else S U star T any number of times. So the whole clean closure we have written over here. So these are the possible things from this diagram. When there is initial and final state only remaining, we are supposed to apply this formula. When there is finally only one state, and that state is the final state as well as the initial state, means only one possible transition can be made here, that is only the self loop. That self loop can be written as or clean closure, R star it can be written as. So if you want to eliminate any of the intermediate node, means you can apply this formula. After eliminating all the intermediate nodes, and finally when there is only the initial state and final states are remaining, this formula can be applied. And when there is only one state remaining, and that too is going to act as the initial as well as the final, this expression, this formula can be applied. Let us discuss one example now. So I have taken this DFA diagram. I am just going to frame the regular expression for this diagram. So if you check, I totally in this NFA diagram, totally there are 4 states are there. Fine. So there is one initial and final, and 2 intermediate nodes are there. So we are supposed to eliminate the intermediate states one by one. First we will think about eliminating the state B. So before eliminating the state B, you are supposed to check whether B is acting as the intermediate node for any of the nodes or not. You are supposed to check. Yes, B is acting as the intermediate node for the node A and C, right? So for the node A and C, B is acting as the intermediate node. Fine. If so, which formula we are supposed to apply? R plus Q S star P, right? Some R parameter, Q parameter, S star and P parameter, right? So what is going to be here? Fine, I'll rewrite it. So B is acting as the intermediate state for the states A and C, right? Now we are just going to, since this is an intermediate state, we are just going to call this formula, this expression, that is R plus Q S star P, right? Now what is R here? The direct connection from what? The direct connection from A to C is going to act as R over here, right? The direct connection from A to C is going to act as R. Q is going to be the incoming transition to the state which we are going to eliminate. S star is going to be the self loop for the intermediate state, and P is going to be the outgoing transition from the state which we are going to eliminate, right? So this is the formula we are just going to apply. So here the R value is, whether you need to check whether there is any transition from the state A to C exist or not. Since there is no transition existing over here, we can write null here. Then again you take Q variable here. Q means what? The incoming transition to the state which we are going to eliminate. B is the state which we are going to eliminate actually. So the incoming transition, yes, it is available, that is 1 under the input symbol 1, right? Then again S star. S star is going to be the self loop of the state which we are going to eliminate. Since there is no self loop available over here, this is going to be S parameter. This is going to be epsilon. Since it is self loop, why we are just writing it as epsilon means, when we make a transition, if you want to remain in the same state, means none of the input symbol is actually needed, and that can be represented as epsilon. Then another variable is P. P is going to be the outgoing transition from the state which we are going to eliminate. So P value is 1. Right? Now you just apply all these values on this expression now. R is null, plus Q is 1, S star is epsilon, right? Then P value is 1, right? So finally 1 epsilon 1 dot epsilon dot 1 is going to be 1 1. So this 1 1 can be written, where you will written this 1 1 input symbol will be written for A to C connection. So after eliminating the state B, only three states will be remaining, that is A, C and D. A is the initial state and B is the final state. So we didn't do any change with the C and D and all. So this part will remain the same. Only from here to here we have done some modification. What means we have eliminated the state B. So after eliminating the state B, we are getting the expression 1 1. So we are just going to make a transition from the state A to C with this resultant expression 1 1, right? Then again when you check initial, final, again one more intermediate state is there, that is what? A to C to D, right? Again you apply the formula R plus Q S star P. So here the R is the direct connection from A to D. Is there any direct connection from A to D? No. So we can write R as null. Then again the Q value is going to be the incoming transition to the state which we are going to eliminate. So here the Q value is 1 1 and S is, there is no self loop in the state which we are going to eliminate. So S is going to be epsilon. Then again P is the outgoing transition from the state which we are going to eliminate, that is 0. Now you apply all these values, all this expression on the variable. R is null plus RQ value is 1 1, then S value is epsilon and P value is 0. So it can be, this is concatenated and written it as 1 1 0, right? So this 1 1 0 will be written on the transition from A to D, right? Now after eliminating the state C, again after eliminating the state C, our diagram is going to be like this. This is the initial state and this is the final state. From A to D only this resultant expression you are supposed to write, that is 1 1 0, and then sorry I forgot to write the 0 1 transition what was here. So because we didn't do any change with the initial state and final state, so whatever the transition was there existing in initial and final, you need to maintain the same till the end, right? This is going to be your final diagram after eliminating C. Now there is no intermediate state, only initial state and final state is only available over here. Now when there is only initial state and final state is available, you are supposed to apply this formula, right? So the formula is R plus S U star T the whole star, then again S U star. This is the formula, right? So here the R value is what? The R value is, check the diagram, here the R values the self loop from the initial state, the S values from the initial state to final state transition symbol, then again U star is self loop from the final state, and T is final to initial connection, right? Then again S is the direct connection from initial to final, and U again is the self loop from the final state, right? This is how we are supposed to check. Here R is what? The self loop from the initial state. So the self loop in the initial state is 0 or 1. We have made a self loop with the input symbol 0 and 1. And the S symbol is the direct connection from initial to final, that is 1 1 0. Then again U star, right? U is going to be the self loop from the final state. Then again T is going to be the connection from final to initial. Since there is no connection from final to initial, it can be written as null. Now you combine all over here. So 0 or 1 plus 1 1 0, again 0 or 1 the whole star dot null. Then again S value is 1 1 0 0 or 1 the whole star. Since we are concatenating these expression along with the null, the entire term will become null. So finally, sorry, there the whole star will come, right? Okay, here 1 star because the whole star. Fine. So finally we'll get 0 or 1 the whole star. Fine. This entire term will get ignored because we are concatenating along with the symbol null. So finally 0 or 1 the whole star, then 1 1 0, then again 0 or 1 the whole star. Fine, this is the final expression. If you check the diagram, 110 substring must be there, and the initial can be anything and ending can be anything. That is what we have represented here, and this is the final expression. Fine, this is one example. We will take one more example with 3 states. Fine. So now there is one initial state and one final state and only one intermediate state. So how many times this Q2 is acting as an intermediate state, you are supposed to check. Like if you take Q1 and Q3, yes, for Q1 and Q3 it is acting as an intermediate state. Q1 to Q2 to Q3 it is going, right? This is one possibility. Is there any other possibility that Q2 is acting as an intermediate state? Yes. If you start from Q3, Q3 to Q2, Q2 to Q3 again. So 2 times Q2 is acting as the intermediate state, right? Fine. So if you want to remove this Q2, you need to apply the formula twice, because for 2 different transitions it is acting as an intermediate state. First we will take Q1, Q2, Q3 now. So to eliminate the intermediate state, we are supposed to use the formula R plus Q S star P, right? What is R here? The direct connection from Q1 to Q3. There is no direct connection from Q1 to Q3, so it can be written as null. Then again, Q is what? The incoming connection. So the incoming connection to the state which we are going to eliminate is what? 0. S is the self loop from the state which we are going to eliminate. Since there is no self loop in the state Q2, we are writing epsilon, and P is going to be the outgoing transition from the state which we are going to eliminate. P is what? 1. So when you combine all this, you will be getting this null plus what? Q value 0, then again epsilon 1. Finally this can be ignored, so finally you will be getting 0 1. Fine. We didn't completely eliminate Q2 now, because only one step we have processed, another step is yet to be processed. So the second possibility is what? Q3, Q2, again Q3, right? One more step is there if you want to completely eliminate the state Q2, right? So Q3 to Q3, right? So again you apply the formula Qs star P. So what is R? R value is what? The direct connection from the state Q3 to Q3. Yes, we have a direct connection from the state Q3 to Q3. That is what? 0. Q is going to be the incoming connection, incoming transition to the state which you are going to eliminate. Yes, from Q3 to Q2 we have a connection, that is 1. If you take S star, there is no S value, there is no self loop, so it is epsilon. P value is the outgoing transition from the state which we are going to eliminate, that is 1. When you combine all this, we will be getting 0 plus 1 epsilon 1, right? So what will come? 0 or 1 1 will come. Fine. So we have processed these 2 steps. Now we can completely eliminate the state Q2. So after eliminating the state Q2, this is going to be your final diagram. 0 and 1. Now what transition can be made over here? Q1 to Q3, the expression is going to be 0 1. So from the state Q1 to Q3, the expression is going to be what? 0 1. Then again Q3 to Q3, the expression is going to be 0 or 1 1. So because why I am ignoring this 0 means, okay fine, already 0 is there, you can combine also, no issues. Else you can completely ignore it and you can take the new expression. The 0 is already included, so 0 or 1 1 we are adding it, right? So this is the final expression. So this is the initial state and this is the final state. So when there is only initial and final state is remaining, we are supposed to apply this formula R S U star T the whole star S U star. Now, what is R value? R value is a self loop from your initial state, that is 1, right? Then, what is S value? S value is what? The direct connection, that is 0, 1. U value is the self loop from the final state, that is 0 or 1, 1. S value is 0, 1. U value is 0 or 1 1, right? And again T value is the connection from final to initial, there is null, so T value is going to be null. then again okay, t value is going to be null. Now you apply all these expression in this formula. Now r is 1 plus s value 0 1 and u is 0 or 1 1 the whole star and t is null, right? The whole star. S u star, S value is again 1 1, u is 0 or 1 1 the whole star, right? So when you concatenate something along with the null, the entire part will become null, right? So finally 1 the whole star, then 0 1 0 or 1 1 the whole star. This is the final expression for this DFA diagram. 1 star 0 1, yeah, 0 1 substring must be definitely there, 0 1, and ending can be either 0 star or else 1 1 star, right? 1 1 star. So this is the final expression. So this is how we are supposed to convert from finite automata to regular expression with the help of state elimination method. Thank you.